Let's examine an example involving calculating a volume. A diver has a lift bag filled with 3 cubic feet of air at a depth of 85 feet of seawater. What would she expect the volume of air in the bag to be at the surface? Now we could use Boyle's law for this. However, I think it's easier to just use the general gas law and eliminate any variables we don't need, because we can assume they're the same on both sides and they cancel. Our general gas law states that pressure times volume over temperature will equal the pressure times volume over temperature. P is the absolute pressure, which is our gauge pressure plus 1 for the atmosphere at the surface. V is the volume of our gas, in this case it's air, and temperature is absolute temperature. I'll talk more about that in an example where we're using the temperature. So we need to know the pressure depth, we need to know the pressure on the surface, we already know the volume at depth is 3 cubic feet, and then we want to find the volume on the surface. To find the pressure, we do depth divided by 33 feet in seawater plus 1 atmosphere for the pressure on us at the surface. If you're doing this in fresh water, it would be 34 feet in the denominator. So for the pressure depth, we're going to have 85 feet over 33 feet plus 1 atmosphere. We line up the units because those are going to cancel. That's good. We don't want feet in our pressure. We want it to just be atmosphere. The units cancel so we know we're doing something correctly. This will come out to be 3.58 atmospheres. So P1 is 3.58 atmosphere. Now we're ready to find P2, or the pressure at the surface. Again, pressure equals depth over 33 feet of seawater plus 1. So pressure is going to be 0 feet over 33 feet plus 1. At the surface, we have no water pressure on us. You may have already calculated that and say, oh, we're at the surface, so it's going to be 1 atmosphere, and that's perfectly fine. So the pressure on the surface will be 1 atmosphere. Okay, now we're all set. We can finally calculate this. For the purposes of this problem, since there's no information on the temperature, we're going to assume it's the same on the surface and at depth. Since the T1 and T2 will be the same, they just cancel out. They kind of go away. If we did all the algebra, they'd end up dividing each other out eventually, and it would be a non-issue, so we can eliminate that. So we're really just doing pressure times volume equals pressure times volume. This gives us 3.58 atmosphere times 3 cubic feet will equal 1 atmosphere times the volume at the surface. We'll multiply that left-hand side together, the 3.58 and the 3 feet, and then we're going to divide by the 1 atmosphere. That will give us the volume at the surface all alone on the right-hand. So that gives us 10.74 cubic feet times atmosphere divided by 1 atmosphere equals the volume at the surface. Now we have an atmosphere on top, atmosphere on the bottom. Those units will cancel. And that's good because volume is measured in cubic feet. It has nothing to do with atmosphere. So finally we get volume at the surface equals 10.74 cubic feet.